Hello, and welcome back to Dr. Logic Awkwardly Does Logic in the dark. In the previous video, we talked about how to do substitution within terms, and in this video, we're going to build on that to talk about how to do substitution in a formula. The basic rule of thumb is that we will only be substituting for free occurrences of our variable. So this is why it was so important that we had this distinction between the free occurrences and the bound occurrences. If a variable is bound, you can't do anything with it. If it's free, then you can possibly substitute some other term in for it. So just like with the definition of substitution in terms, the definition of substitution in a formula is going to be recursive. We'll tell you how to do substitution for the atomic formulas, and then how to do the substitutions for each of the more complex formulas: negations, conjunctions, disjunctions, conditionals, and the quantified formulas. So let's bring up the whiteboard and get defining. So definition, this is substitution of term tau for variable x in formula phi, done in a recursive fashion. So if we have, let me fold my notes, and because it's dark, I will have to peer at them awkwardly, but awkwardness is the name of the game. So if phi is of the form r tau 1 up to tau n, or tau 1 equals tau 2 for some n-ary relation r and terms tau 1 to tau n. So if it is an atomic formula, then phi with tau substituted in for x will just be, in the first case, take your n-ary relation and then do the substitution on each of the terms. So from tau 1 all the way up to tau n, substitute tau in for x according to our definition of substitution in a term. Or it will be the result of substituting tau in for x in tau 1 and taking the identity of that with the result of substituting tau in for x in term 2. So basically, if we have an atomic formula, we just shove the substitution into the terms and then appeal to our definition of term substitution. If phi is of the form not psi, where psi is some well-formed formula, then the result of substituting tau in for x in phi is just going to be the negation of the result of substituting it in for psi. And it's going to be similar for the binary connectives. So if phi is of the form psi 1 or psi 2, psi 1 and psi 2, or psi 1 implies psi 2. So let's just make it easy. Say, let this little star represent any of disjunction, conjunction, or implication. Then the result of substituting tau into phi is going to be, you guessed it, the result of substituting it in for x in psi 1, and then take whichever connective it is that you have, disjunction, conjunction, or implication, and concatenate. I don't want to say conjoin because it needn't be conjunction. The result of substituting tau in for x in psi 2. So these are fairly straightforward. We just kind of pull the connective out and look at the substitution instance of the subformula. Where things become a bit more complex is at the level of the quantifiers, naturally. So we've got a couple of cases because we need to pay attention as to whether x is free, x occurs freely in the formula or not. it's always going to be free if we don't have a quantifier. If we have a quantifier, it might potentially occur bound. And then those cases we don't want to substitute. So we've got two cases here. So if phi is for all y psi or exists y psi, and then in this case where y doesn't equal x, because remember we are substituting in for x. So if we're looking at another variable, then essentially nothing changes. So it will just be the same as taking the substitution of tau for x in psi with, again, you just pull the quantifier out to the outside, or if it's the existential quantifier, it'll be the result of substituting tau in for x in psi and then having exists y out front. So the last case then is where we have actually a quantifier that matches the variable that we are trying to substitute in. So this quantifier captures any remaining free occurrences of that variable. Now, some of these occurrences might already have been bound kind of deeper into the subformula, but if, say, psi had x free, then for all x psi, we'll have it bound through our definition of free and bound variables. In this case, so we're looking at the case where the quantifier binds the variable that we are trying to substitute. Then the result of performing substitution just is the formula we started with. So the way you can think about this is when the variable occurs bound, no substitution happens. In any other case, you just push it down into the subformula, and eventually you will wind back up into the case of the atomic formula, and then you just look and you see, okay, how do I do the substitution if I have terms that I'm substituting in? Because remember, all variables occur freely in terms because terms don't contain any quantifiers. So there you have it. I encourage you to write down some formulas and pick some variables and pick some constants or some other terms, whatever you like, and just try working your way through these definitions in order to show what counts as a substitution instance and what doesn't. In fact, I think I will probably give another video separate from this one where I just go through some of these examples so that you can see exactly how it works. But here's the definition. It's all you need to know. Go forth and calculate your substitution instances. I will see you next time. Take care. Cheers.